Okay, we're back, and I did the first 20 problems, and this is homework. The first 20 problems took me about an hour, and that's me yammering through it. And someone says, "Oh, an hour is a lot of time to spend." Not really. It's not a lot of time to spend. You're spending roughly, in classroom about 12 hours a week in the classrooms at Essex County College. And I'm going to say, as a general rule, you probably should be spending, you know, at least 10 hours of study time. I will say if you want to be competitive, it's going to take more than 10 hours of study time per week. For my class alone, by the way. Let's write this down now. I say it's an infinite geometric sum, and I'm just not seeing it yet. So what I want to write down is, looking at it, I'm looking at this, I'm wondering, how did they get from term to term? Well, I'm going to look at these two first, and I'm noticing it looks like they multiplied the bottom by 4. It looks like they multiplied the top by 3. So let me see if the common ratio is actually, in fact, this thing over here, which is 3, 4. Right? So I'm looking at it, and I'm going to see, like, that means A1 is equal to 8. But let me put this down. 8 times 3 quarters. And what would that give me? It should give me 6, by the way, and it does. Let me do the next one. 6 times 3 quarters. And what do you get over there? Well, that would be what? That would be 18 quarters, right? And 18 quarters is 9 halves. Well, that works out beautifully. Let's do the next one. What's the next one going to be? 9 halves times 3 quarters. And what do you go there? 27 eighths. It's working out beautifully. So what do I know now? I know what A1 is, and I know what R is. So then the question is, what's the infinite sum? And there's many ways to do it. I'm going to say probably the formula is probably the way to go, if you can remember it. If you can't remember it, I want to point out there's a way to get by without remembering it. And I'll put this down for you. So I'm going to write down S as the infinite sum. I'm going to make an erasure over here. And I want to remind you how these formulas are derived. You multiply both sides. I'll write this down for you. By the common ratio. And what was the common ratio? I hope you remember. It's 3 quarters. So if I multiply both sides by 3 quarters, what do you get? 3 quarters S. And what do you get on the right side? I'm sorry, on the left side if you multiply by 3 quarters. Well, you would get 6 plus 9 halves plus 27 eighths plus yada, yada, yada. Now I'm looking at these two guys over here, and I'm going to subtract them now. So what would I get? Let's write this down. If I subtract, well, I notice that all these things would be disappearing. So you'd be left with 8 equals, well, S minus 3 quarters would actually be 1 quarter of an S. So what's the S equal to now? S would equal to 32. Now this is making some assumptions over here. One of the big assumptions is that the common ratio is less than 1, and certainly the common ratio R is certainly less than 1. It's 3 quarters. So this is the sum. All right? Let's go over here and notice this over here. I want to point out they also use the formula. And let me remind you what the formula is. It's going to be A1 times 1 over 1 minus R. Let's write this down. What's A1? A1 was 8 times 1 minus R. What was R? 3 quarters. I would probably multiply top and bottom by 4. What would you go there? 8 times 4. 4 minus 3. 8 times 4 is 32, and 4 minus 3 is 1. We still get 32. All right? The formula was derived for you. This is the formula for an infinite sum, provided that the R was a proper fraction. All right? All right, 22, a little more complicated. They have which of the following functions is increasing for all x. Boy, this is deja vu, isn't it? So I'm going to, kind of looking at it, and I'm kind of looking at the cube root function. Cube root functions sort of look like this over here. So I can say that appears to be increasing forever. Now the sine function bobs up and down like this over here. This is no good. That's not increasing forever. What's the natural log function look like? Well, the natural log function looks like this over here, and that looks like it's increasing everywhere. What does e to the minus x look like? That looks like this over here, which means it's decreasing. So that's decreasing forever. Where they want to know increasing, so I'm going to say these two. Let's see if they got that. They said f of x, and they said h of x. All right? By the way, they do say on their domains. That's true. Find the domain. Ooh, this is a tough one. So what do I got over there? I notice there's a root problem, and the root problem is good everywhere. I'll tell you why. X squared plus 9 is always a positive number. What I have to worry about, though, is the bottom ever equal to 0. Let me write this down. Is the bottom ever equal to 0? Well, let me write this down. X squared plus 9, the root of it, is equal to 5. I'm going to square both sides. X squared plus 9 equals 25. Let's see, x squared would equal, I'm going to take 9, that would be 16, right? So x would be plus or minus 4. So I'm going to say if x is plus or minus 4, that you would have division by 0. So I'm going to say the domain of this thing is going to be all the real numbers. However, you cannot allow x equal plus or minus 4 in. And why is that? You get a division by 0, and that would be bad news. That answer is listed for you over here. All right, let's look at number 24. Number 24 says the cosecant is 3. That means the sine of theta is 1/3. And they say the secant of theta is that number there, which means the cosine, I'll write that down for you. The cosine of theta is 4, 3 root 2. Now, what are the questions? The question says, find the exact value of each of the following. Now, the first one says, what quadrant? Well, they want an exact answer over here. What does that mean? First, second, third, or fourth, or possibly some combination thereof. So let's take a look at that. And what do I know about this? I want to determine where the sign is positive. And the sign is defined as being the ordinate. So the sign's going to be positive here, and the sign is going to be positive here. All right? It's negative otherwise. Now, so why do I say that? I'm looking at these things. I know the sign is positive. Now, where's the cosine positive? The cosine is positive here, but it's not positive here. So that's no good. Now, by the way, this is my only choice now. All right? First quadrant. Okay. What's the sine of theta? 1/3. Let's see if they put 1/3 down. Yep. Ooh, they asked for the tangent of theta. Let me write this down for you. The tangent of theta is sine of theta over the cosine of theta. Do I know the sine of theta? It's 1/3. Do I know the cosine of theta? It's 4 over 3 root 2. Let me write this a little differently. What does this look like? 1/3 times 3 root 2 over 4. What happens over here? Cancellations. And what do I mean by that? The 3's cancel. I mean, left off with root 2 over 4. Let's make sure they got that written down. And I'm saying that this is root 2 over 4. Let's see how we did. If I make a mistake, I'll correct it. Oh, yeah, I got it right over here. Cosine, I think I put that down already, 4 over 3 root 2. Yep, got that. Now this one's secant of 90 degrees minus theta. It's more difficult. I know that. And someone's going to say, I wonder what this is all about over here. And, certainly I'm looking at it, and I'm kind of curious about what this means to me. So the secant of 90 degrees minus theta. And this sort of reminds me of things that you've done in the past, by the way. Now, so I realize I don't remember any of that stuff over there. And so, I'm going to say they told me this is the secant over here. But then I got to remember, this looks like those even-odd identity. I'm sorry, these cofunction identities that we talked about before. So what would this equal to me? Let's take a look. I got to be careful here. So I want to write down some of these things that we did before. So the sine of 90 degrees minus theta is the same thing as cosine of theta. And these are identities you learned in Math 120, by the way. And you did a bunch of them. So I'm going to cut to the chase, and I don't want to put them all down. But the secant of 90 degrees minus theta is going to equal the cosecant of theta. Now, do I know the cosecant? I don't think so. But I know the sine of theta. And you may say, I can't remember that. The sine of theta is 1/3. So what's your cosecant? It's reciprocal. It's just 3. All right? Not bad. All right, this is an identity problem, and we need to verify the identity. And my suspicion over here is you need to choose a side. If I were choosing a side, I would choose this side. Reason being, it allows opportunity to work. I'm going to look at it, and I'm going to just go one step at a time. I'm going to circle this. That's what we told you to do in Math 120. This is a Math 120 question again. Let me see if I wrote this over here as Math 120. This is Math 120. Let me see if I did this one. This is Math 119. And this is, I'm going to say you'd have to know math up to Math 120 for that. But it also was covered, not the sine function, but it was covered in 119 about increasing, decreasing. This one over here is Math 120. And this one over here is Math 119. And this one over here is Math 120. Sorry about that. I should have probably said, oh, you know what? I'm really going backwards. We got to, I don't want to keep doing that. Let's do this. Again, if you're confused at any point, please come by during office hours. There's many ways to do the problem. I'm not saying there's one way to do it. But probably what I would do is I would probably split into two fractions. Secant squared theta over secant squared theta minus 1 over secant squared theta. Well, what does this give me now? This gives me 1. It's conditional, but we're not worried about the conditions. Minus cosine squared theta. Well, what does this give me? It's a Pythagorean identity, and this would give me sine squared. Is that what I want to show? Yep, I want to get that. So I'll just put down QED now. I did what I was expected to do. Okay, this one says algebraically, exact answers and approximate to 3 decimal places. This is Math 119. What do you get over here? I'll write this down for you. This is 2 natural log 3x equals, I'm going to say 19, right? All right, what I do over there, I added 2 to both sides. Now the natural log of 3 to the x is equal to 19 halves. Now I'm going to write it as an exponential. 3x is equal to e raised to the 19 over 2. And now I can solve for x exactly. So it's going to be e to the 19 halves divided by 3. This is the exact answer. Now, by the way, I'm really not interested in approximate answers, but you should learn how to use a calculator. So on a calculator, x could be written down on a calculator this way. It would be e, this is on your calculator, a little caret key, then it would be 19 divided by 2, and then you would divide that by the number 3. Now, you may be surprised if you do this on a calculator, your calculator is going to return, it's going to return the same thing to you. It's not going to do anything. But once you put a decimal into the calculator, it's going to approximate it. And this is what we want you to get across to you. Please learn to use a calculator. And what do you get over there? You would get this number over here. Now, that's accurate to 3 decimal places. And what do they say over there? 3 decimal places. If you're not getting these numbers, you know what? Maybe I made a mistake. Maybe you want to come back and see me. All right? Now, this one over here, a little, I'm getting a little complicated. It's starting with an odd number, 51. When I say odd, I'm not saying 51's the odd number. I'm just saying usually we start these at 1. So what I'm going to do over here is I'm going to look at it. I notice that this thing really is the same thing as 6 times n equals 51 to 100, and then I'm going to say n over here. Now, so I'm going to say, there's many ways to do the problem. I'm not saying there's only one way to do it, but I'm going to do it a little differently than I've done it in the notes. And what I'm going to do is I know formulas, and I hope you know some formulas as well. So I'm going to say this is really, looks like, n equals 1 to 100 of n, but I got to remove something from it, don't I? And I got to remove n equals 1 to 50, and we'll get the same answer, don't worry. Now, someone says, why do you do it this way, not the way it's done in the notes? I'm just going to say there's options for doing the problem. What do you get over here? Well, let's write this down for you. This is some of the integers from 1 to 100. So that's going to be 100 times 101 over 2 minus, well, the next one's going to be 50. Let's take a look at that. And that's going to be 51 now over 2. Yeah, I know it's tough. Let me take a look at that. I'm going to write it down for you. I'm going to factor the 2 out. This would become 3. 100 times 101. Yeah, they're nasty. Minus 50 times 51. You know what I'm going to do? I'm going to factor out of 50. That's 150. Let's see. What would you get there? 2 times 101, which is 202, minus 51. Again, I hope I didn't go so fast you can't follow. But one thing that's about watching videotapes, you can always stop the video and say, I'll watch it later. I also get exhausted watching people work, by the way. I'm not exhausted when I'm working, though, but I'm exhausted by watching people work. It's exhausting. Get to work. That's what I'm talking about. Stop watching videos. Get to work. So what's 202 minus 51? That's going to be 151. I can do the work now. So 150 times 151. What's that going to be? 150. 5 times 0 is 0. 25. 5, 7. Wow, that was tough. 0, 0, 0, 5, 1. Whoops, I really kind of jammed that in there, didn't I? 0, 5, 6. Let's see, 5 and 7 is 12, right? 22650, right over there. I was doing okay. All right, this one says, write the linear system of equations represented by the augmented matrix, then back substitute to find the solutions over here. This is math 119 now. Well, the first equation is x minus y. They tell me what the variables are, by the way. Plus 2z is equal to 4. The second equation is y minus z is equal to is equal to 2. And the third equation just says z equals minus 2. So at least I know what z is. And now I'm going to use back substitution to figure out what y is. So what would you get over there? You would get y plus 2 equals 2. So I'm going to say y is equal to 0. We'll check the key later, by the way. Now I'm going to take these two answers and plug it back in over here. And what do you get? X minus y. Well, I think y is 0. And I think z is going to be minus 2. That's minus 4 is equal to 4. So what do I get? I get x equals the number 8. Let's check the key, see how we did. I see x is 8. I see z is minus 2. And I see y is 0. Feeling good about that. Next one, this is the arc sine of 1. The way I'm going to do that is the way I teach my students. But again, you may say my teacher told me to memorize these things. That's entirely up to you, by the way. But I'm going to look at the invertible region of the sine function. And when does the sine equal 1? At the number pi over 2. Got it. Given, wow, they gave me a lot. I'll tell you what they've given me really helpful to me. They give me the roots. So if that's true, I know that f of x is equal to, well, one of the roots is 2. That means one of the factors is x minus 2, and the other factor is going to be x plus 3. What I don't know is the remaining factor over here, but I do know it's quadratic now. How do you know that? Well, this guy here is quadratic. When I divide that through, it'll be quadratic. I just want to briefly go through how you do that, and that would be x squared. Minus 2 plus 3 is plus x minus 6. So I'm going to do the division to find out what the remaining factor is. And I'm going to divide it into 2x4 plus 7x cubed. Yeah, it's tedious. Minus 4x squared. What I do know about this, though, if they're truthful, this will work really nicely with 0 remainder. If they're truthful, by the way. It would be awful to lie to a student at this point, though. What do you get over there? 2x squared. That would give you 2x4 plus 2x cubed minus 12x squared. What do you get over there? Well, it looks like you get 5x cubed. Let's see, plus 8x squared minus 27x minus 18. Well, it's going to be 5x now. What do you go there? 5x cubed. Let's see, 5x squared minus 30x. What do you get over there? 3x squared plus 3x minus 18. I'm going to say plus 3. That's a 3, by the way. You get 3x squared plus 3x minus 18 is 0. So, you know, I got partially factored now. I'll get my eraser out. I'll erase this over here. Now, what is this thing over here? It's 2x squared plus 5x minus 3. And I think I'm ready to go in for the kill now. X minus 2, x plus 3, 2x, x, let's see, it looks like 3 and 1. Oh no, I made a mistake there. That's not correct. I got to think more, don't I? I'm going to say plus, whoops, sorry about that. X, I did it again. X plus 3, that's a 3 over here. And 2x minus 1. Let me just check it. 2x squared, 6 minus 1 is 5x. Yeah, it works beautifully. So it says, use given roots long division to complete the factorization. We got the factorization over here. Exactly what we expected, by the way. I want to point out what I mean by that. We're expecting to see... did I make a mistake? 2x squared plus 5x plus 3. I see it now. I made a mistake. I'm going to look at the k. This is wrong. I copied the wrong thing down. Let me erase this again. Yeah, it's all wrong. I'm going to look at the k. And this is going to be 2x squared. Sorry about that. Plus 5x plus 3. What do you get over here? X minus 2, x plus 3, 2x and x. And I'm going to say 3 and 1 plus plus. That gives you 2x squared. 2 and 3 is 5x. Yeah, it works good. So I think I have it now. And again, I made a mistake. I corrected. And you want to do that too. X minus 2, x plus 3, x plus 1, 2x plus 3. Now it says, use this information to graph it. And, it might be sloppy, but I'm going to put a graph down for you. And, I'm going to write down things what I'd like to write down for you. So the things I'd like to write down is the Y-intercept. And the Y-intercept is going to be 0, minus 18. And there's going to be X-intercepts, by the way. What are they going to be? Well, I'll put them down one at a time. I'm going to say 2, 0. That's this guy here. I'm going to say minus 3, 0. That's that guy over there. I'm going to say minus 1, 0. That's, this guy over here. And I got to do another one, right? What's it going to be? Minus 3 halves, comma 0. So what I want to do is I just want to go to the picture. And I want to make sure I'm looking at a picture. And the picture I'm looking at, I'm going to look at, this is minus 18. This point over here is 2, comma 0. I just want to go back and I want to point out, I just got these two clipped off. Let's do minus 3, 0. That's the point, minus 3, 0. And what's the other guy going to be? Well, minus 1, 0. And what's the other guy going to be? And again, I'm just kind of moving around. It's minus 3 halves 0. I got all those points, by the way. Now, by the way, what they say sign analysis, and someone says, what do you mean sign analysis? Well, it's the very first thing you did in Math 119. So if I did sign analysis, what I'm going to do over here is put the zeros down in order, right? So minus 3. And then what do I get? Minus 3 halves. Minus 1. And then I get a 2. And I'm going to pick points. And someone says, why do you pick points? Because it's easy. A point over here would be like 3. Plug it in, positive, 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 positive. So what do I know? I know the function's up here somewhere. Now, if you go between minus 1 and 2, 0 would be a good choice. And we've already got a test point there, but let's say you didn't remember that. You just plug it in. What do you get? Positive. Again, we're trying 0. You would get positive, in the factors, by the way. Positive, negative, positive. So it's negative. So what I know, it's below. I know that much. Now, if you go between minus 3 halves and minus 1, you might say it's really difficult, but not really. I would pick probably like minus 1.1. And what do you get? Again, I'm doing in the factors. Positive, negative. I'll write this down for you. And then you're going to get negative, and you're going to get positive. What does that give you? Positive. So I know it does something like this over here. It may not be perfect, but good enough for as far as I'm concerned. What's a good point over here? I'd say minus 2. You plug that in, what do you get? Negative, 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 and a positive. What does that give you? Negative. So I'm saying something like this over here. All right? Wow. I go below minus 3. Let's say you pick minus 4. What do you plug it in? Well, you get negative, 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 which is positive. So I can say that's what the picture should look like, and let's see if we've done okay with that. So what I say, to the right of 2 is positive. I'm seeing that here. It said between, let's see, -1 and 2 is negative. I see that. You got a better picture though, right? Then it says the next one is positive. I think I did that okay. And then it said the next one was negative, and the next one was positive. We got that all done, all right? They did a pretty good picture, by the way. All right, let's do this one over here, solve it. Looks nightmarish. I hope it's not nightmarish for you. I hope it's easy peasy lemon squeezy. What do you get? 2x square root 4 minus x equals 3. The root of 4 minus x. Gotta look at my time, by the way. Gotta be careful with time. I'm gonna multiply both sides by the root, 4 minus x. And what do you get? 2x equals 3, 4 minus x. That was easy. What do you get now? 2x equals 12 minus 3x. Well, you're going to get 5x equals 12, or x equals 12 fifths. All right? Maybe premature to box it, but I think you probably know 12 fifths is 2 and 2 fifths. So it seems like it certainly satisfies the non-negative radicands for this over here. But you know what? I know people get tired. So what I'm going to claim over here is please look at the k, all right? But it does say please check it. What does that mean? In the original equation, you check 12 fifths. Let me go through that real quick with you. 24 fifths. Again, if you can't do this, you're not to do it. Now 4 minus 12 fifths. That's going to give you 20 minus 12, which is 8 fifths. Minus 3 times the root of 8 fifths. Now, granted, I know for some students this is absolutely out of the question to do it, all right? Here's the deal, though. I think you could try at least. So let me write this down for you. Let me put this down, 24 fifths. And this is going to be 2 root 2 over the square root of 5. I'm going to multiply top and bottom by 5 root 5s. And what do you get? Let's see. The 5 would cancel. You get 24 root 5s. And what do you get on bottom? You get 10 root 2s. It looks tough, right? Well, let me put this down now for you. What's this going to be? Well, it's going to be 3 times 2 root 2. And you get root 5 in the bottom. I'm going to top and bottom by root 5 now. And what do you get there? Well, you get 5 in the bottom, right? And what do you get on top? You get 6 root 10. I'll write that down for you. Not looking good, is it? Let's keep going. I'm going to multiply the top and the bottom by that first term by root 2. What do you get? 24 root 10 over 20. I'm multiplying by the root of 2, by the way. And this is going to be 6 root 10 over 5. I'm going to reduce this now. I'm going to reduce it by dividing top and bottom by 4. You get 6 root 10 over 5 minus 6 root 10 over 5, which of course is equal to 0. Yes, I know checking can be very difficult. All right, I'm going to take another break, by the way, and I recommend when you're doing homework, you take breaks. You stop, you come back. Now, you might take a 5-minute break, 10-minute break, a whole week break if you want. I don't recommend it, by the way. I do recommend working and plowing forward. But I'll come back and do this next time. Thank you for paying attention.